Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. What does the future hold for the space sciences? More than half a century ago, inspired interest in space exploration was remarkably high among the general public, as humanity's attention was held rapt by the race to the moon. However, in the 21st century, the public face of space science is less the astronaut than the physicist and astrophysicist. When young people wish to learn of space science, they learn of Big Bang, gravity-centric cosmology. They hear of the respective works of Newton and Einstein, and they must try to make sense of concepts such as warped space-time, infinities, and singularities. They're told of a universe that is 96% dark, comprised of matter and energy that are unproven, invisible, and, quote, poorly understood. To find that a scientific foundation exists for any different way of seeing the universe, the young and the curious have little choice but to seek outside the confines of institutionalized science, and beyond the narratives its celebrity spokespersons promote in popular media. On such a journey, one has a chance to discover that an astounding scientific foundation exists for another cosmology, a cosmology which recognizes it is not gravity that governs the universe, but rather electromagnetism. The forefathers of this cosmology are not named Newton and Einstein. They are the giants of electrical and plasma science, the renowned experimentalist Christian Berglund, and the Nobel Prize winners Irving Langmuir and Hannes Alfvén. A universe filled with electrically conducting plasma is not 96% dark. It is alight with electric currents. And the physical mechanisms that spark the phenomena we see are both understandable and easily replicable in laboratories on Earth. Recently, we spoke with a member of the Electric Universe community who has made it his mission to introduce the young and the curious to the ideas of the Electric Universe. His name is Benjamin Hyde, and he is a science presenter on the news station Fox 13 out of Salt Lake City, Utah. We asked Ben to introduce himself and to describe his efforts to spark inspiration and interest in the sciences among today's youth.
This is Benjamin Hyde, and I have been studying physics, specifically quantum physics, for the better part of 2.5 decades. It's been a passion of mine. It's something that I love and I really enjoy. And now, 2.5 decades later, I realized that the reason why I was so fascinated with it is because I like understanding the fundamentals of things, reality. And quantum physics, from my old understanding, was that where that explanation was going to come from. You know, I wanted to know what everything was made of. And so I studied it, and I did what everybody in this field did. You know, I just took what was given to me and accepted it. And because I didn't have anything different at the time, I said, okay, this is what it is. And it didn't really dawn on me that it didn't make sense. And if it didn't, I'm just like, well, I'll just roll with it. I remember specifically a few years ago when dark matter and dark energy really hit the stage, and I learned that, 96.5% or whatever it is of the known universe was either dark matter and dark energy. And I thought, wow, that is a profound amount of stuff in the universe that we don't know anything about. So I justified it in my mind that basically anything was possible because most of what we knew, we didn't know. So as I'm studying quantum physics, particle physics, cosmology, I of course ran across videos from the Electric Universe, because I would go to YouTube and I would watch, Brian Greene, the World Science Festival videos, loved those for a while. And of course the Electric Universe videos would pop up every once in a while, and I'm like, great, I'll watch those too, and I did. But what happened, and this is funny, every time I would study physics, I would get to a burnout mode. I would study it for a few weeks, and I would just get so frustrated that I just would lose interest in it. And now, looking back on it, I realized that was because I was studying nonsense, and I was trying to bang this garbage stuff into my head. And there was a part of my head that was just saying, Ben, this isn't real. This is a mistake. So after one of these up and down times with quantum physics, I I went into the electric universe and became enthralled. I learned who David Talbot was. I learned who Wal Thornhill was. And I learned what they had to say, and it was just captivating. And as we all know, all of us who are in this understand this feeling of like, oh, finally, all the stuff we've been studying our whole lives now finally makes sense. And I've never stopped. And what was interesting is that I never went back into that up and down pattern of studying it and then not studying it. I've just been constantly studying electric universe stuff because, we don't know everything. And there's still questions, clearly, but it feels like we're on the right path.
For a person with a previous focus in mainstream physics and cosmology, we asked Ben what might have caused his shift in interest toward the electric universe.
I think what it was is that I got to the point with particle physics and quantum physics where it was just so absurd that I couldn't help but drop it. Drop particle physics. The whole idea that a thing can be both a wave and a particle is just so colossally absurd that it begs to be dropped. The fact that the electric universe, I think the first thing that really got me into it is the fact that they were talking about that everything in the universe is basically moved and affected by charge differential. I played with a battery. I've rubbed my feet across the carpet. I can create a charge differential. You can see it. And the lightning discharge between my fingertip and a wall socket when I rub my feet across the floor is just a scaled down version of lightning, what I see in the sky. And then when the electric universe talked about scaling, I'm like, scaling? Yes, I understand scaling. Because one of the things I found out that was just absolutely absurd, another one of the absurdities in the current model, is that quantum physics wasn't scalable. I'm just like, wait a minute, guys, if there are fundamental principles of the universe, they would, by definition, have to be scalable. But quantum physics, by its own definition, says that our rules, the quantum physics rules, only work up to the scale of maybe a molecule, and everything smaller than that. And above that, they don't work. That's just silly. In every sense. It just defies common sense. And I got to tell you that this is getting a little personal, but at the time I was going through a faith crisis, a faith transition, and I just learned that everything I had been taught, religiously up until that point in my life was also it was just a story. And all of a sudden, when I allowed myself to think that, everything in my life suddenly made sense. All the ideas and questions I had that religion was supposed to answer that didn't answer, I realized I had just been making justifications for. And so when I lost the ability to justify what I had been told, that skill leaked out into science. And all of a sudden, I saw the same things with quantum physics and with science in general, that I had been just assuming and justifying and rationalizing what these teachers of science have told me my whole life. And so it was easy in that respect to go into the electric universe because they had very simple concepts that were easily identifiable, stuff that you could do at home in a very, very simple sense, which is what I've done, to show the principles. See, I could never show quantum principles here at my house. Or to the kids that I teach. You could never do that. The closest it came was pointing a laser at a double slit and saying, look, you can see refraction patterns. But, even then, you're not demonstrating that life is both a particle and a wave. You're just telling people that that's what's happening. And that's as close as I could ever come to demonstrating the principles of quantum physics. And I'm thinking, if there's actual, real, fundamental laws of the universe, they should be demonstrable and they should be scalable. And that was one of the first things that Wallace Thornhill talked about, and mentioned that I think was it Hannes Alfvén said that the effects of the plasma cosmology were scalable to like 10 to the 19th or 10 to the 16th. I'm like, great, perfect. That envelops the macroscopic world that I can interact with and the cosmological world. Perfect. Let's go.
After beginning his research into the concepts behind the electric universe, Ben began performing his own experiments on electric universe geology. That is, reproducing the familiar features of planets and moons through electrical discharge to a solid surface. We asked Ben if he could identify the catalyst for his own experimental research.
Of course, it was Valles Marineris and, Wall and David talking about how that they're scallop craters and that electrical discharges could do this. I'm like, I was just fascinated because it was so brilliant to see Valles Marineris and realize how big it was. And the thought that electricity could do that was just captivating. So I was, of course, looking for how to do this. It was really funny. I was so blind by this. It's amazing because I had in my possession a transformer that took 120 volts and bumped it up to 12,000 volts, and I've had that for years, but it never dawned on me that I could play with it until I told one of my coworkers about the electric universe, and he said, "You know what, Ben? I've got a transformer at my house that I use to create Lichtenberg patterns in wood." I'm like, yes. That's what I'm talking about. And he said, "I'll give it to you." And so I'm like, great, I'll take it. But I didn't even realize that I already had one in my possession. I'd been using it to create a Jacob's ladder for my science experiments for the kids that I do with Spark Science. And so I ran out and dismantled the probes, or the two electrodes from my Jacob's ladder, and just put them on a dust plate, like what you say, the little metal plate, and then I just created an electrode out of a screwdriver, and bam! I started throwing different powders on there, different dust, and just creating, the butterfly effects that we see, the lightning scars, everything that the electric universe geology folks deal with. And it was just fun. And so I've just been out there for the last month throwing different powders on there. As a side note, I'm actually a licensed pyrotechnician, which means I build fireworks as well. So I've got a whole arsenal of different compounds, and I'm really curious to see how they all react to an electric field. And so I've been putting each one of these in the different fields, and I found that boric acid works, creates some really interesting effects. Baking soda creates really interesting effects, and charcoal creates really interesting effects. And I've not gone through and tested all of my powders yet, but I'm in the middle of that. But that's what I do. And then I post a lot of this stuff to Facebook Live and to my Spark Science channel. And it's so fun. And anybody can do it.
Like many other members of the electric universe geology community, Ben himself resides in the American Southwest. We asked Ben if this locale provides unique opportunities for exploring electrical geology concepts.
Yes. Oh, absolutely. It literally feels like I'm at ground zero for these supposed electric discharge phenomena that happen between the Earth and Mars, as we understand it. Now, I realize that the Earth has a couple different places on it that have, just striking features, but Utah is one of them. Now, I live in Utah Valley, and the Wasatch Mountain Range is to my east. I mean, I'm literally 5 minutes from it. I can walk to the mountains. Well, there is a canyon just like 10 miles away that was featured in Andy Hall's episodes. And he's take pictures of it, and he talked about it, and I've always noticed it. It's startling because you have the mountain range that's basically smooth, and then all of a sudden there's this horrible jagged crack right there, and then the mountains get smooth again. And I've gotten out, I've taken pictures of it, I've actually hiked up this canyon. My father-in-law lives right at the base of it, right at the mouth of that canyon, and we've just explored it. And then seeing that Andy Hall thought it was significant as well, I finally went up there and climbed up there and have taken pictures. And I told you this before, but the rock cliffs up there's one of them that has a hairpin turn in it. Now, regardless of whether that was electrically made or lava made or whatever, it was something catastrophic and well worth, investigating. When I learned about these different features, I started looking at Google Earth in my local neighborhood, and everything that everybody talks about, these wind-driven triangular buttresses, I can see in my own backyard. It's amazing. I mean, just right here in Utah County, how Andy Hall describes triangular buttresses and supersonic winds is right here. I mean, I don't even have to go to Google Earth. I just could literally walk outside. So I've been pulling out my astronomy binoculars, looking at the mountains. We just got back from a family vacation down in southern Utah. We were 30 miles away from Canyonlands and a lot of the features that Andy Hall has talked about. And so this is what I did, and this is what I'm doing right now. In fact, I'm glad that I have this platform to talk, because I want people to send me rocks and soil samples from wherever they live, because I want to put them under my arc and see what they do. Because I just brought 2 samples back of rock that look very volcanic rock from southern Utah, and soil samples. And as soon as I'm done here talking to you, I'm going out and I'm putting them under the arc to see what they do. And of course, I'll film it and share it with everybody. I'm going to show you here what the arc does with baking soda, and you can see right here is that as I turn on the arc, this butterfly pattern just erupts. I mean, you can see that it comes down to a point. It creates a chevron here, and the moment that I turn it on, you'll see the poof of dust going around it, which tells us that there are particles of the baking soda that are ionized. Not all of them, but enough of them are to where they're immediately expelled from the region. And if I do this just right, and if I position the electrode in just the right area, you will see that the arc will form. It'll strike the powder and create a little nodule, I guess is what I call it. But as the arc dissipates, or if I make the arc, if I bring it further away from the dust plate and just go back to the electric field effects, you'll see that little nodule remains. It stays in place. And you can touch it, and of course you can smash it with your finger. It doesn't take much. But what's interesting is that it's like it's that instant petrification that we hear about, that Peter Jupp talked about. It literally looks like something like that is happening. It forms a little column, a little bead, that holds itself in place even though all the dust around it, as you can see, is flying away, is being excavated. Now, with this one is barium, or not barium, I'm sorry, barium also makes green in fireworks. This is boric acid. And as you can see, if we apply the arc to it, boric acid also burns green. But as you'll notice, it also can create these beautiful butterfly effects. And these are the same ones that we see in different places all over the planet. Andy Hall has pointed them out, very, very stark examples of them in southern Utah. People in the group have talked about the ones in Russia, but they're everywhere. And you can create them in the lab right here. The last one I have is just charcoal, which of course is just burned wood. It's carbon. And as you can see, as I turn it on, strike the arc, you get a big cloud of dust, of just excavating the dust. And then as we let the arc continue, it will form that familiar chevron shape or butterfly. It just depends on how long you leave the arc. If you leave it on for a few minutes, you'll get the full butterfly wings, as you can see. If you leave it on for just a couple seconds, you'll get the formation of the chevron, which you can see. So I'm not done. Those are just the 3 most interesting ones that I've found. And I'm going to do more. I'm going to use just regular dirt. I've got clay I'm going to use and try and create that effect that Wall Thornhill and Dr. Ransom created. But that's still up and coming. I don't have that done yet.
Given the significant differences between the electric universe and standard cosmology, we asked Ben for his thoughts on the best approach to introducing the subject to newcomers.
Well, there's 2 things that strike me. The last time I was in public talking about this, I said the following. I said, science is all about learning and progress. And if anyone ever tells you that we have decided and we've finally landed on it, you know that that's not science. And everyone, they know that. And so I start off my conversation with them and I tell them that. And then I say, our old knowledge is that comets were icy snowballs. But we have since sent out probes that have landed on comets, and they've taken pictures, and we've seen that they're not icy snowballs. And here's those pictures. So the icy snowball was the old thinking, from Fred Whipple in the 1950s, and the new knowledge that we're gaining is this. That's palpable. That's a spoonful of sugar right there. That's not saying that all science is wrong and scientists are stupid and they're egotistic maniacs that are just chasing the dollar. I was able to explain it like that, and the people responded, very well. It was palpable to them. And that was the adults. Now the kids are actually a lot easier, because kids, especially at the age that I deal with, mostly, right around 10 years old, they are naturally curious. They have big questions. And I know this because I have 8 kids myself, and I've got 5 of them in that range right now. They ask me about, where did the universe come from? Just big questions. And it's not because their dad is really into science. It's because they themselves are interested. And so when I tell them that the things they're learning in school are stories, they are an explanation based on our best knowledge at the time, it's easy for them to say, oh, what else is there? And I say, well, here's what else is there. So kids, it's really easy to introduce them to this stuff because they're naturally curious. So you don't have to come up with clever, soft ways of telling it. You just answer their questions.